Friends, welcome back to my channel. In last video we discussed the function of this circuit card. This is grade 2-ton inverter AC board. The reported fault for this board is E6, communication error, that this board is not responding to indoor unit. Most commonly when we find communication error, our first checkpoint is these optocouplers. When the transmission or reception optocoupler is bad, the board will not respond to indoor unit. But sometimes there are other faults other than these optocouplers. The same here. In this board, we found this IGBT short circuited. When it is short circuit, it will not allow to turn on this board. When it will not turn on, its circuit will not active, its microprocessor will not active. In result, it will also cause to fail to communicate. For good communication with indoor unit, the board must be powered on properly and there is no overcurrent condition or anything wrong. If anything wrong, especially overcurrent condition, at that time it will turn off its startup circuit. When it will disable this circuit, next circuit will off, processor will off, power supply will off, it will not respond to indoor unit. There are different techniques in different boards. When we study different brands, the working concept, working phenomena is always same. Let's start to troubleshoot. If you don't have good practical experience in power electronics, never try to repair because it have non-isolated live electrical voltage. When we are working on this board, never touch any component when power is applied, first thing, and when we are touching to this board, remove power. After removing power, always verify voltage on these capacitors. If there are voltage, discharge it properly. In the first step, we will perform cold testing. First of all, set multimeter to voltage and verify voltage here. If here are some voltage, discharge it. Set multimeter to diode or continuity, positive terminal, and IPM this section, negative terminal, and these emitter pins, these resistors 1, 2, 3. So we have good connection between positive line and negative line. While connecting red lead at negative terminal, connect black lead at UVW. It is giving 0.45 volt on each pin. So it is internal diode for low side IGBTs. That means it is good. If we find continuity here, that time the IPM IGBT is bad. If we find continuity here, or we find any one diode open, we need to replace IPM. Now connect red lead at positive terminal and check at UVW. Output leads, it is open. It is good condition. Now black lead at positive terminal and check here. 0.45, 0.45, 0.45. Now the high side 3 IGBT diodes are good. If we find short circuit or open, at that time the higher side IGBTs are not good. Remember that we tested just only IGBT, this rectifier, and we also verified the channel. If IGBT is short circuited, it will give continuity. If this diode is short circuit, it will give continuity, because in each phase we have two IGBT, negative, positive. And this is output terminal, positive, negative. We tested these diodes. We have three sets in one IPM. As we tested, if it is giving continuity in this way, that we are finding diode drop voltage, that means this channel is silent because its gate is controlled by internal IC. Now check these diodes. Verify these IGBTs. So we need to remove these IGBTs. Connect black lead at bridge rectifier. This diode in the bridge rectifier is short circuit, so bridge rectifier is also damaged. We will remove bridge rectifier and we will remove these IGBTs. Diode, black lead at positive terminal, red lead here, so it is short circuited. We need to replace it. Now we need to remove these IGBTs. This IGBT is damaged, so we cannot test it, and it is the cause to damage this bridge rectifier. And if we check this IGBT, it's good. This IGBT is good. One IGBT is good, one is bad. So we will turn on this board without these IGBTs and without this bridge rectifier. So we need to verify this section. The second thing, to turn on this board, we need to jumper J2, J3 connector. Why we need make jumper? Because this circuit supply, after this protection circuit, EMI filter, it will reach to PTC. First PTC, second PTC, and then it have a turn on relay, power on relay. Then the voltage will go out to the bridge rectifier. And then we have bypass relay. When we apply power, the voltage will reach here at the contacts of this relay. When this relay will on, then it will allow to flow current through these PTCs. Then voltage will reach to bridge rectifier and it will provide to booster section. Voltage will reach here. When voltage are maintained, at that time microcontroller will turn on this relay, bypass relay. At that time, full current will pass to the next circuit. To turn on this relay, we need to turn on this power supply. To turn on this power supply, indoor unit must be connected. Voltage will reach here. It will charge this capacitor by means of this PTC. this voltage from here, it will reach to PTC, this PTC, and then voltage will reach to this capacitor. It will turn on this power supply. If we will connect without communication wire, the voltage will stop here. It will not pass to next circuit, it will not pass to this supply, it will remain off. In the first step, to verify this argument, I will connect power without this jumper, that is here. I will apply power using series lamp. Now I applied power to this board, AC voltage, same 228 volt at this inductor. If these are not reaching here, that means this fuse is damaged. Output of this inductor, second inductor outside, 227 volt. This neutral, it is reaching here at this capacitor. Now if we see at this point, 228 volt voltage are here. Then first PTC, second PTC, and voltage are stopped at this point of relay. When it will turn on, at that time it will pass this voltage through this jumper to fuse. Then this voltage will reach to this NTC here, then this voltage will reach here. Now it will not allow to pass any voltage to this capacitor. If you want to turn on this board without indoor unit board, at that time we need to connect this jumper. Through this PTC, the voltage will reach to this circuit and it will receive voltage. This circuit will turn on, it will turn on, and then supply will start to reach here through PTCs. If the bridge rectifier is installed, then the capacitors will start charging. After that, it will turn on this relay. Now let's connect this jumper. Verify voltage here, no voltage. Verify voltage here, no voltage. I will connect 1 ampere jumper at these 2 points. Now I installed jumper and I will check AC voltage at this point. Relay is now turned on. This relay is now turned on. LED will blink at specific number to generate error code, and at the same time this microcontroller will send error code to indoor unit that there is problem with DC rail. Here are no voltage at this line. Now we will check voltage at SMPS section. DC voltage at this capacitor, 308 volt, 12 volt, this 15 volt for IPM, then this small capacitor here, it is after regulator. After that, this small capacitor here near this regulator, 3.3 volt regulator. In the first step, power supply must turn on. It will turn on, it will turn on this relay. This relay will close its contacts and supply will pass to SMPS circuit. Then this voltage will reach here to communication circuit. And we can verify now voltage here at communication capacitor. It is 58 volts. So this supply must be present to send command signal, communication command signal to indoor units. So these are the power supply checkpoints. Now to verify the next circuit, I will connect this small bridge rectifier, because this is the original one. It is D25X8. Because we are not turning on the next circuit, we will verify the voltage here. Now I applied power using series lamp, and we can see the power supply is turned on and the relay is turned on. This LED is turned on. DC voltage, we have 268 volts because we are applying power using series lamp. If I will connect direct power, now without voltage booster, we have 323 volt because we removed IGBTs. When we have IGBTs and we will connect indoor unit boards, at that time it will boost the voltage at these canisters. I will arrange the IGBTs and we will continue next troubleshooting. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching.